Welcome to PlayOwnAi. We'll build test case Gemini agent. That AI powered. Build your own free AI test case generator agent, Local LLMs plus Google Gemini plus PDF input. Ollama plus LangChain plus LLM in Python with VS Code. Beginner to mastering tutorial step-by-step guide. It's simple. In this project, we've organized everything into 3 main files inside our directory. Test cases gen tool, IPYNB. Here, we'll run our test case generator agent with local LLMs. Generate test cases. Reset my password using a link sent to my email. Generated test cases shown on screen for the above requirement. Different scenarios. Like password reset link. Clicks on the invalid password reset link. Successfully resets password, etc. We'll also explore how to use 2 different LLM models. One for agents and another for tools, so they can work in parallel execution. Test cases gen tool Gemini, IPYNB. This file takes things further by replacing our local LLMs with the Google Gemini model using Ollama. We'll also add requirement gathering features from an external tool, directly integrated into our existing code. Test cases gen tool Gemini PDF, IPYNB. Finally, this file demonstrates how to run the test case generator AI agent with requirements gathered from a PDF. That means we can take a real document and instantly generate structured test cases powered by AI. By the end, you'll not only learn how to run test case generation with free local LLMs, but also how to upgrade it with Google Gemini and even handle PDF requirement gathering. All step by step. This project is perfect for anyone looking to enhance their software testing process with AI. Whether you're a developer, tester, or just curious about the possibilities of AI in tech. Key learning objectives. 1. Setting up the environment. 2. Run test case generator agent with local LLMs. 3. Using 2 LLMs model for agents and tools for parallel execution. 4. Using Google Gemini model instead of local LLMs with Ollama. 5. Writing requirement gathering features from external tool in our existing code. 6. Running the test case generator AI agent with requirement gathered from PDF. If you're finding this tutorial helpful so far, don't forget to hit the subscribe button and turn on the notification bell at PlayOwnAi. That way, you won't miss my upcoming videos on AI, local LLMs, and automation tutorials. 1. Setting up the environment. First, let's set up the environment. If you've already configured your system for running local LLMs, you can simply skip this step. Otherwise, follow along as we go through the setup process. To save your time, I'll play this part a little faster than the rest of the video.
Ollama on Windows machine. I am on google.com and I will type Ollama for Windows and hit enter here. The first link is from Ollama.com. Let's click on download Ollama on Windows. Here you can see download for Windows button is visible. Let's click on it to install Ollama on Windows machine and you can see Ollama setup has been started. The setup is approximately 273 megabytes in size. So let's wait for few seconds while setup is being downloaded. Ollama setup has been downloaded successfully. Let's click on it and start the setup. This is how the setup looks like. Let's click on install to continue with the Ollama setup on our Windows machine. As Ollama says, it helps us to run LLMs like GPT, Llama 3 and other models on our local system. But based on, let's maximize this and zoom in. And let's type Ollama here and hit enter. And you can see Ollama can be accessed from any location in CMD. Before we run some commands with Ollama, you can see that Ollama supports a list of models that are available on Ollama.com library. Let me open this in a separate tab. We will review it as well. Now they have given some example models that can be downloaded using Llama. For example, Llama 3, with 8 billion parameters takes around 4.7 GB space on our system. Similarly, Llama 3 trained with 70 billion parameters will take around 40 gigabytes of space on our machine. So now here comes the catch. We need to have at least 8 gigabytes of RAM available to run 7B models. It means if we want to run Llama 3 model that has been trained with 8 billion parameters, it means we need to have around 10 gigabytes of RAM available to run these models. Hence in my case, I have 16 gigabytes RAM on my system and I will be able to run this model. But if you have only 8 gigabytes of RAM, then I would recommend that you run smaller models like Mistral, Neural, Chad Starling or Code Llama. That takes less space because if you try to run Llama 3 with 8 billion parameters, your system performance will be quite slow. Yes, you might be able to run this, but your system might be slow or it might crash. Now let's take a simple example. Using this command we can run a model. So let's do that. I'll use llama run to run Mistral model, which is trained on 7 billion parameters. So let's do that. I'll switch to command prompt. And here you can see we can pull a model from a registry using pull command. Now you will understand what is the purpose of pull command and how to run a model. So let's do that. If we run a model directly internally, it will first pull a model file on our local system and then it will run it. Let's clear the screen type Ollama to run a model which as well. Let's first see the response provided by large language model. The first use case identified by the Mistral model is automated test case creation. Generative AI can be used to analyze software code and automatically generate test cases based on the identified patterns, structures, functionalities. This can significantly reduce the time and effort required to manually create test cases. Improving. If you're using macOS or Windows, simply click the download button for your operating system and follow the standard installation process. For those on Linux, we'll use the command line. Open your terminal and run this single command to install it. Use 2 commands to add your user to the Ollama group and set the correct permissions for the models directory. Once that's done, you can verify your installation by typing Ollama version. This should confirm that Ollama is installed and ready to go. That's it. Now that we llama 3 or DeepSeek R1 to view detailed information and get the exact command you need to run. To start, let's try a smaller model. Now, let's try a more powerful model like Llama 3. We'll use the latest version to get the most up-to-date model. In your terminal, type Ollama run Llama 3, latest . Again, Ollama will download the model for you. It might take a bit longer, but it's worth it. Once it's ready, let's chat. I'll start with a simple greeting. Hi. The response is much more conversational. Hi, it's nice to chat with you. Is there something on your mind? Quote. Now. First, we need a code editor. I highly recommend Visual Studio Code, which is a powerful and free editor. Go to code.visualstudio.com/download. Download the version for your operating system and follow the simple installation steps. Next, we'll install Python 3, which is the programming language we'll be using. Visit the official download page at python.org/download/source. Download the latest version for your system. A quick tip for Windows users: make sure to check the box that says Add Python to path during installation. This will save you a lot of hassle later on. If you're on a Linux system, Python 3 is often already installed. To verify your Python installation, open a new terminal or command prompt and type Python 3 version. If you see a version number, you're all set and ready to move to the next step. We'll get you set up with Jupyter in VS Code, enabling powerful interactive programming and data analysis. First, let's open VS Code from your terminal. Just type code and press enter. Once VS Code is open, we need to install the Jupyter extension. The easiest way is with a simple shortcut. Press Ctrl+Shift+X. This opens the extensions view, a sidebar where you can browse and manage all your extensions. In the search bar at the top, type Jupyter. Click Install on the official Jupyter extension from Microsoft. This will also install other necessary extensions for a full experience. Now, let's set up a project environment. For a clean workspace, it's a good practice to use a virtual environment. Let's create a project folder. In your terminal, type mkdir POI agent to make a new directory. Next, go back to VS Code. From the File menu, select Add Folder to Workspace and choose the new POI agent folder. Now, navigate into your new project folder in your terminal. You can do this by typing cd POI agent. Next, we will create the virtual environment. Type Python 3 This command creates a new, isolated Python environment named venv in your project folder. Finally, you need to activate this virtual environment. If you are on macOS or Linux, The command is source venv bin activate. Your terminal prompt will now show the name of your virtual environment, indicating that you're ready to install packages and start using Jupyter Notebooks. Now, let's install the core framework we'll be using for our project, LangChain. LangChain is a powerful framework that will allow our Python code to easily communicate with Ollama. You can find more information and the official documentation at python.langchain.com. To install the specific package that connects LangChain to Ollama, open the terminal in VS Code. It's important that you do this from within our project folder, which contains our virtual environment. Type the following command: pip install LangChain Ollama. This command installs the library we need to access Ollama's features from our code. Once that's finished, our entire environment is set up and ready to go. To start coding, our project folder will new folder for Python, like PlayOwnAi agent, venv, lib, Python 3.13. Let's create a new file in our project folder. We'll call it start here, ipynb, which is a great format for an interactive notebook. Open File menu, create new file as Jupyter Notebook, ipynb support file. Now, let's start working in our Visual Studio Code environment. We need to give our a title. Open your start here, ipynb file. In the first cell, click the plus markdown button. This will create a new markdown cell. Inside this new cell, type a title using the hashtag symbol, like this, #start here. Now, you can either click the green check mark to save the cell or simply press Shift plus Enter. This will render the markdown and save it as the time, and type in a new name. Now that our notebook is titled and saved, we're ready to move on to the next step. Right side kernel menu. We can see the kernel is set to Python 3.13x. Clicking plus code will open a code cell where we can write our Python code. Print. Hello, playing with Python is fun. PlayOwnAi. Prompt window. Visual Studio Code. Running cells with venv. Python 3.13.5. Requires the IPy kernel package. More info. Change kernel. Cancel. Install, click it. After install, complete run or execute code block. Output. Hello, playing with Python is fun. PlayOwnAi. Click the plus markdown button. This will create a new markdown cell. Inside this new cell, type a title using the hashtag symbol, like this, #LangChain start. Clicking plus code will open a code cell where we can write our Python code. Pip install LangChain. LangChain Ollama. LangChain OpenAI. LangChain embeddings. Click the plus markdown button. This will create a new markdown cell. Inside this new cell, type a title using the hashtag symbol, like this, call Ollama model. Clicking plus code will open a code cell where we can write our Python code. From LangChain _Ollama import chat Ollama. LLM chat Ollama. Model Llama 3. Latest. Base URL localhost 11,434. Temperature 0.7. Max tokens 1000. Versus code terminal type. Ollama list. That show the models available in your Ollama server. Click on execute cell to run the code. It will execute it without any error. In terminal, run Ollama list to see the available models. To run the model, use Ollama run less than model _name greater than. For example, to run the Llama 3 latest model, use Ollama run Llama 3 latest. You can also use Ollama run Llama 2 to 7b to specify a particular version of the model. To run the model with a specific prompt, use Ollama run Llama 3 latest prompt. Your prompt here. Click the plus markdown button. This will create a new markdown cell. Inside this new cell, type a title using the hashtag symbol, like this, #invoke message with LangChain. Clicking plus code will open a code cell where we can write our Python code. Response equals LLM. Invoke. What is capital of Bangladesh? Print. Response. Content. Click on execute cell to run the code. It will execute it and show the output in the cell below. The capital of Bangladesh is Dhaka.
Keycap 2 running the test case generator agent with local LLMs, exploring how to leverage free local large language models using Ollama. Open VS Code and navigate to the directory. Create directory for the project. Test case generator agent. Click Test case generator agent. Now create a Python file named Test Cases Gen Tool. IPYNB. Click the file to open it. Add markdown cell and add the below text. #test case generator agent with local LLMs. Or any other name you prefer like Gen Test Cases Tool. Save the file on Workspace directory. Create or copy PDF file in the same directory with PDF. In my case, I have copied the PDF file named LLM_introduction.pdf. It will be used as input to the agent last step. Add Markdown cell and add the below text. Hash install required libraries or packages. Add code cell and add the below code Python. Pip install LangChain community. Pip install unstructured, etc. Click Run cell to install the packages. First use one of them and later we will see how to use both of them. Add code cell and add the below code Python. From LangChain Ollama import chat Ollama. LLM chat Ollama. Base _URL localhost. 11,434. Model Qwen 2.5. Latest. TC_LLM chat Ollama. Base _URL localhost. 11,434. Model Llama 3. Latest. Add Markdown cell and add the below text. ## connect Ollama to local model. Add Markdown cell and add the below text. ## create the agent with tools. Add code cell and add the below code Python. Import Oz. From LangChain, tools import tool. From LangChain, prompts import prompt template. Def generate test cases. User story stirrer. Generate test cases from a user stories. Return the test cases in Markdown format. Prompt template from template. Greater than entering new agent executor chain. I should generate BDD test cases based on the given user story. Action. Generate _test cases. Action input. As a user, I want to reset my password using a link sent to my email, so that I can regain access to my account if I forgot my password. Observation. Generated BDD test cases for. As a user, I want to reset my password using a link sent to my email, so that I can regain access to my account if I forgot my password. Thought. I now know the final answer. Final answer. Here are some generated BDD. Behavior-driven development. Test cases based on your user story. 1. Scenario. User receives an email with a password reset link. Keycap 3 using 2 LLMs model for agents and tools for parallel execution. Now, let's take things to the next level. Instead of relying on a single LLM, we'll use 2 different models. One dedicated to running the agent and the other focused on executing the tools. By doing this, we can achieve true parallel execution, which makes the workflow faster, smarter, and more efficient. This setup allows each model to focus on its strengths while working together seamlessly to generate accurate test cases in real time. Now we will use second LLM's model. Just enable code. Open terminal. Type Ollama list. It will show all LLM. Copy the name of LLM we want to use. Passed on second LLM. Like TC_LLM chat Ollama. Model Llama 3. Latest. We will used on create tools function. That used for parallel execution. Just change code on last. Like add TC_LLM. Return TC_LLM invoke prompt. Initialize agent with proper tool section. Use old LLM as like before. Summary of this section. Create tool use TC_LLM. Llama 3. Latest. Execution tools section use LLM. Qwen 2.5. Latest. Click run and execution code. It must be faster and better result than previous single LLM. Execution result. 4. Using Google Gemini model instead of local LLMs with Ollama. So far, we've been running our test case generator agent using local LLMs through Ollama. But now, let's see how we can switch things up by using the Google Gemini model instead. This allows us to connect to a cloud-based LLM that brings in more advanced reasoning power and broader context handling. The great part is, you don't need to change your entire workflow. We'll simply integrate Gemini into the same setup, replacing the local LLM while still keeping Ollama available as a fallback option. This flexibility gives us the best of both worlds: the reliability of local models and the intelligence of Gemini when needed. Now, let's make a duplicate copy of our existing notebook test cases Gen tool, IPYNB. We'll rename this new file as test cases Gen tool Gemini, IPYNB. This way, we can keep the original notebook for local LLM experiments, while using the new Gemini version to integrate Google's model. Keeping separate notebooks makes it easier to compare results side by side and switch between local and cloud-based LLMs without breaking our workflow. Next, we need to create a .env file inside our workspace directory. This file will securely store our API key for Google Gemini. To get your key, visit istudio.google.com/app/API-key. Here, you can either generate a new key or use an existing one. Once you have the key, simply copy it and paste it into the .env file. The content should look like this: Google_API_key equals AI. Make sure to keep this file private and never share your API key publicly. Don't use my key, I will delete it. Now let's visit the official LangChain documentation at python.langchain.com/docs/integrations/chat Google Generative AI. Here, you'll find the guide on how to initialize any Google Generative AI model in just one line of code. Before that, we need to make sure the required package is installed. So let's copy this command and run it in our notebook. %pip install LangChain Google Gemini. This will install the latest LangChain integration for Google Generative AI, allowing us to connect and run models directly in our workflow. Now let's click Run to execute the code and generate our test case output. First, we'll test it with Gemini 2.5 Flash. This model is optimized for speed and delivers results almost instantly. Next, we'll switch to Gemini 2.0 Flash to compare the output and see how it performs with the same prompt. By running both, you'll clearly see the difference in response style and speed between Gemini versions, giving you a better idea of which one fits your workflow best. Step 5. Writing requirement gathering features from external tool. Now that we've set up our Gemini notebook, the next step is to prepare a version that works directly with PDF requirements. To do this, let's simply make a duplicate copy of our existing file. Test cases Gen tool Gemini, IPYNB. Once duplicated, rename it as Test cases Gen tool Gemini PDF, IPYNB. This new notebook will specifically handle requirement gathering from PDF documents, while keeping the Gemini integration intact. In the next step, we'll add the document loader code and run it with real PDF inputs. Now let's move on to integrating requirement gathering directly into our existing code. Step 6. Running the test case generator AI agent with requirement gathered from PDF. Here, we'll use a document reader to process files from an external source. The logic remains almost the same. Rename tool as generate test cases from PDF. But now we're pointing it to a folder called docs, where our input files, like PDFs, are stored. I'll copy this entire block of code and paste it into our notebook. Let's walk through it together. Text will be like, reads the requirement from the PDF and generates at least 10 test cases scenarios in BDD style format. Now let's read our requirements directly from the PDF documents. First, we'll set up the folder where all our PDF files are stored. Here, the folder name is simply PDF. Docs, PDF. Documents. Next, we loop through each file in this folder. I. For file in OS, list dir. Docs. Fillpath OS, path, join. Docs. File. Print. Fillpath. Loader unstructured file loader. Fillpath. Instead of extending everything at once, we'll load each file and then process its contents. Docs loader, load. For doc in docs. Now we have a list of documents where each entry contains the **** file name **** and the page content. To keep things efficient, we'll join only the first few sections of text into a single string called requirement_text. Requirement_text join documents. This ensures we're working with a clean, focused input, instead of passing the entire PDF at once. Finally, we'll define a prompt template for our LLM to understand how to generate the test cases from this. Requirement text. Prompt template from _template. As you can see, this loop scans through the docs folder, prints out each file path, and loads them using the unstructured file loader. This way, all your external requirements, like PDFs or text files, are automatically pulled in and ready for processing within your AI agent. Now let's initialize our agent so it can work directly with the PDF requirements. We'll start by importing the agent class from LangChain. From LangChain, agents import initialize agent. Agent type. Next, we'll set up our agent. Notice that we are passing in our tool called Generate Test Cases from PDF, the LLM we want to use, and the agent type, here set as OpenAI functions. We're also enabling verbose true so that we can see detailed logs while it runs. Agent initialize agent. Tools generate test cases from PDF. Agent type. OpenAI functions. Verbose true. Finally, we'll run the agent by passing in our input, which is the requirements.pdf file, and then print the results. Result agent.run requirements.pdf. Print result. This will generate test cases automatically from the PDF requirements using our AI agent. Click Clear All Output. Top section of the editor. Restart and Run All button click and Show AutoGene Generate Test Case from PDF file. Feature. Learning about large language models. LLMs. Through the self-contained introduction. Scenario 1. Successful comprehension by target audience. Valid case. Given a user with basic machine learning knowledge, when they access and read the self-contained introduction to large language models, then they should be able to understand the fundamental concepts of LLMs. Scenario 2. Navigating the modularized design. Valid case. Given a user is viewing the self-contained introduction to large language models, when they navigate through the documents sections, then the content should follow a clear modularized design, progressing from a high-level overview to specific details. Support line. Get assist. Stuck anywhere, or feeling overwhelmed? No worries. You can download the full workflow directly from my GitHub at Matinict, my LLM. Just follow the link in the description. For more tutorials and smart automation tips, visit my YouTube channel at PlayOwnAi. Still need help? Feel free to drop a comment below. I personally reply and I'm happy to assist. Thanks for watching. If you found even a bit of value, please subscribe and hit the bell so you don't miss my next AI automation guide. Your feedback helps me create the most useful content possible. So, what's on your mind? Tell me what you're struggling with in comments. I might just build a full tutorial on it for you. We release new videos every week. Let's build smarter together with PlayOwnAi Playground.